So let's do some more questions in chapter 8. We've challenge that would be, let's see, this. We haven't done 36. Yeah, we haven't done 36. Okay, let's do this one. So the numeral 47 in base A represents the same number as 74 in base B. Yeah, and then we're just gonna find out what A and B, what A plus B is, what A and B is. So you guys have any idea? So basically what it says is that 47 in base A is equal to 74 in base B. Okay, and this is from A and 10. So
4A plus 7 is equal to 7B plus 4.
yeah, very nice, yes. Okay, so does everyone else have a problem with this? It's 7, so 47A and 74 in base B, right? In different number bases, we'll learn how to represent the value of the number using an expression, right? So recall that if it is in base 10, you do 4 times 10 plus 7, and the other one is 7 times 10 plus 4. If you have more digits, there'll be 10 to the 10 squared, 10 cubed, and 10 to the 4th. That kind of thing. Do you guys remember, right? If it's in, say, base 3, then there will be a number times 3 plus a number. If it is in base 8, that's 4 times 8 plus 7. Okay, are you guys good with this? Remember? This as a review. So Ryan is correct. Very good. That will be, so the first number will be 4A plus 7. Second number would be 7B plus 4. Okay, very good. And how do we know the smallest value of A and B?
Move A and B to one side and 7 and 4 to the other side.
Okay, so there'll be 4A minus 7. Okay, maybe let's make it positive. So let's say 7B minus 4A, right? And then that will be 3. Very nice. And what do we do next?
So in this case, B equals to 1 and A equals to 1. So B and A are the same number.
Okay, both of them could be 1 and to get a 3, but do you think a base 1 system is possible?
No, because in base 1 system, there's only 0.
Yeah, and also since there was 4 and 7, that means A and B must be at least how much?
8.
8, right, guys? Okay, Ricardo, that makes sense? You have a 7 here, right? So for A and B, they both have to be at least 8. Otherwise, you wouldn't have a 7, right? So we start from 8 and then think about this and maybe try to find a pair of numbers that would work.
B can be 9 and A can be 15.
Very nice, yes. B is 9, A is 15. Yep, very good. Okay, how do we figure it out? Yes, it's just by trying. Casework. Yeah. So this one you have to try, right? So you start with maybe because 7B has a bigger coefficient, right? So you can start with the B. If B is 8, then that will be like 56. Try it doesn't work, then try b equals 9, and it works, right? Yeah, so it wouldn't be hard. Okay, Ricky, right? That makes sense. You start with b equals 8, and then try b equals 9, and you'll figure it out. And obviously, this will be the smallest because b cannot be 8. If b is 8, 8 doesn't work, right? So that'll be just 9 and 15. Yeah, very good. And that's it, right? So a plus b, that'll just be 24. And this will be the answer. Okay, see from AMC 10. Okay. Okay, next we have 39, 41. Just do an AMC question and let's call it. And this one. This is also from AMC. Okay, see if if you can make sense of the question. It's basically saying that this cryptographer, he's gonna the cryptographer means like he's encrypting numbers, right? He's making passwords sort of stuff, right? So what he is doing here is that he's translating a number into base 5 and using VWXYZ. So basically, in base 5. Yeah, Rika. Yeah, Rika, very nice. Yes, got it. Yeah, that's the correct answer. Yeah, very nice. Okay, so Rika already sent me the correct answer. Very good. Yeah, so VWXYZ are just you could say there are 5 digits in base 5, right? Which are 0, 1, 2, 3, 4. And the engineer is using these 5 numbers to code some integers and stuff. And he finds that 3 consecutive integers are coded VYZ, VYX, and VVW. And he's just looking for what is XYZ coding in the base 5 way and find out its base 10 expression. Okay, so we basically we're just gonna figure out what XYZ, and of course by doing that we if we wanna do that we have to figure out what VW are, right? Basically VWXYZ, what they are, like they have to be 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, like these 5 digits, right? We have to find a match, one-to-one correspondence. Okay, so Rekha, since you did it, could you tell us how you did this one? How did you start it?
就是 okay, it's a bit complex to explain, but like,
你用中文解释一下。
VYX 加1 VVW，然后呢 because like it is like base 5。So 就是他说 causes 5 digit to change 嘛，那么就是x 肯定要减4 ，if it must be having a change, it must equal to 4。
Yes, and then
然后呢W 等一下，让我再写一遍，是0。然后呢，VYD plus 1 equals to VYX. We have x，那么 x 应该是等于 z 加1。
所以 z 就是3。
Yeah, z 是3。然后呢，继续嘛，like byx 是加1是 vvw。然后呢 again 就是会加1嘛，那么 v 就等于 v 就等于 y 加1。然后这样我们已经就是已经做出来了嘛 ，v 就等于2。然后就是 convert 就行了。
Yes, very nice. 非常好，非常好。Okay. So I'm gonna recap. So what Reka said, the starting point would be this equation. Okay, because if you look at this one doesn't really tell you anything because that's literally z plus 1 equals x, right? Z plus 1 equals x, and vy are just gonna still be vy. So there's no clue or any telltale sign from this, right? But this can tell you a lot. This, if you observe, the middle digit changed, right? So why does the middle digit change? It must be from a carryover from the unit digit, right? So it has to be the case where x plus 1, this part, it reaches 5 so that it carries over, so that it becomes something 0. And there's one more digit here, like 1 carried over. So v is 1 more than y. Okay, does that make sense to you guys, right? So from this equation, we can see that this has to be a carryover thing. That means x is 4. Right? So here we have to carry over in order to become this, right? So that means x is going to be 4. And if x is going to be 4, 4 plus 1, that's 5, but it's base 5, so it becomes 0, right? So w equals 0. And then we also will know that v is y plus 1. Y plus 1, y get a carryover from unit digit becomes v, right? Okay. And now we can know what z is because we've already known that x is 4 and z just 1 less than that, right? So z will be 3. So 3, 4, 0. And again, we only have digits from 0 to 4. Now we already matched 0, 3, and 4. That means we only have 2 and 1 left, right? Only 2 and 1. So that means y is going to be 1 and v is going to be 2. Okay, and in the end, we can plug in and then look at the result and see if that makes sense, right? So the first number here would be 2, v is 2, y is 1, z is 3. The next number is 214, and that all makes sense because x is 4, right? And then we plus another one. We don't have 215 because you have to carry over. It's space number 5, it's space system 5, right? So there'll be 220, the next number. And 220 is VVW. W0, V is 2. Okay, so that means everything makes sense. Okay, any question, Aaron, Lily? All right. Okay, good. And in the end, we just need to find x, y, z in base 5 and convert it. So x is 4, y is 1, z is 3 in base 5. We converted this 4 times 5 squared plus 1 times 5 plus 3. And that would be 108. Okay. Yeah. Okay. Very good. So Rika, did you just do it, or did you have you done it before? 你刚刚直接做的吗？还是之前做过了？
Yeah, 没有。
哦 ，OK， 厉害厉害。
So I skipped this question like before.
哦 ，OK， very nice。你现在就知道怎么做了，对吧？挺好的啊。OK， 然后我们看一下，这里还有一个。你看这个 ，How many integers from 1 to 1992 inclusive have a base 3 representation that does not contain a digit 2?
So why don't we convert 1 and 1992 to base 3 first?
No, we can do that. So 192 to base 3.
So the highest power of 3 that is just below 1992 is 3 to the power of
let's write it down. So 3 to the power of 4 is 81, right?
81. Yeah, 3 to the power of 5 is 243.
Yes, 243. So 3 to the 6th times another 3. So we have 9, 2, 7 to 9, right? So we need to time by another 3.
Yeah.
Do we need to?
We don't need to because it would be 22,000 something, so we don't have to.
Yeah, if we time by another 3, 3 times 7 is 21, so we have 21 something. Actually, we have 2187, right? So that's more than 1992. So note this, just 3 to the power of 6. Very good. And what times 3 to the power of 6?
Well, then we need to divide. We need
We can just guess,
2.
right? It's not, yeah, we can just
2.
guess. Yeah, it's not too hard, okay? So times 2, that would be what? 1, 4, 60, 58.
Yeah.
And we do a subtraction, right?
Yeah.
So we do have 5. So 5, 4, 5, 3, 4. Okay, so now we have 5, 3, 4 as a remainder. For 3 to the 5th, what do we do?
Times 2.
Times 2. Very nice. And then there will be times 2, it'll be 4, 8, 6. So do a subtraction. That's 8, 4, 1, 2,
38.
4.
48.
Yeah, 48. So 48 means that the next number is 3 to the 4th, that's 81. So is there any 81 in 48?
No.
No. So that means we do what? We put a which number here?
3 to the power of 3.
Yeah, we just put a 0 here, right?
Yeah.
For 3
yeah.
to the 4th. Yeah, 3 to the 4th, we have a 0. And
Yeah.
3 cubed, that's 27. So which number?
1.
Yeah, just 1. And then we have
21.
21. Yeah. So for 21, we have 9. How many 9s?
2.
2 9s. So 2 times 9, 18.
3. So it's just 1 times 3.
Yeah, 1 times 3.
1.
And the last one should be 0, right? Another 0 at the end. Okay, so that means we can convert it to base 3. That would be 2, 2, 0, 1, 2, 1, 0. 2, 2, 0, 1, 2, 1, 0 in base 3. Okay, very good. Okay, so basically from 1 in base 3 to this big number in base 3, and we're gonna count how many integers among them don't contain a digit 2, right? Okay, so what is a trick to this? Previously, we have done some similar problems. So problems that where we have a situation in which so you have some base system, but in the base system, some digit, 1 digit or maybe 2 digits or maybe 3 digits do not work. Like you cannot have them, right? Once we deal with this kind of situation, we can just see the question as, in this case, it's base 3, but one of the numbers you cannot use. So that means it's basically like a binary system. Right, remember? So previously we have done some similar questions. Let's have a look. Trying to bring back some memories. For example, it's 841. Remember, this is from this is basically a base 10 system without a digit 4, right? So as we explained before, if you're skipping 4, you only have 9 digits, then it just seems to be a base 9 system, right? See if that makes sense? Because you only have 9 digits, right? In this problem, you only have 3 digits is base 3, 0, 1, 2. And if you're not allowed to use 2, that means you can only use 0 and 1. So that's exactly like a binary system, right? And remember, there's a question, if I remember, 835. This question, although it was in base 7, but we can only use digits 1, 3, 5. So since we can only use 1, 3, 5, it's sort of like a base 3 system. So in the end, we use a bunch of 3s, remember? See, base 3. Because you only have 3 possible digits to use. So it's, when it's 1 digit or 2 digit, it's just like base 3 system. So that's why we use a bunch of 3 powers of 3. Okay, yeah, we've done these 2 questions that are pretty similar to this one, okay? So that was a big hint. You guys have any other idea?
Like 128.
128? Yeah, very nice. Yes, how did you figure it out?
I did this question before the class.
Okay, good. So how do we figure out like what number we're gonna use in binary, right? Now notice that this number contains a lot of 2s, right? It contains a lot of 2s, so you can imagine that numbers that are close to this number don't work, right? They have to use a 2. If you look at a leading digit here, that's a 2, right? So for example, 1991 or 1990 or 1989, 1988, all of these integers wouldn't work, right? Because they will start with a 2. Does that make sense? Right? So you want to start with a 1. So that means how many digits do we have? We have 7 digits here, right? We have 7 digits here. The largest number you could get without using a 2, that will be 111, 1111, right? Seven ones. That makes sense, right? Okay. And again, since we don't really have the digit 2, that means all the numbers that should be counted is going to be from, well, so 0 and 1 and 10 and 11, 100 and 11, 101, 110, 111, right? So all the numbers that can be counted would just actually be a binary number in, binary number 111, 111. Right? So basically all the numbers you can have is 1 and then 10 and then 11 and then 100, 101, 110, 111, and then 1000, 1001, etc. Right? Because there's no digit 2. You cannot use digit 2. So even if you're in a base 3 system, only these numbers can be counted. And until when? Until this number, right? Because this number, if it is in base 3, right, back into base 3, this number is the biggest number before this number, before 220, 1210, that you can have without a digit 2, right? So you can only count from 1, 10, and all the way to here. And basically, because you cannot use digit 2, it becomes a binary number, 111, 1111. See if that makes sense? Any similar question like this, if in any base number, say base number n system, if there's 1 digit you cannot use, you should see it as n-1 base system. If there are 2 digits you cannot use, you should see it as n-2 base number system, right? So on and so forth. Okay, so in the end, this is just 2 to the 7th, so 1 to 8. Any question? How many integers have a base 2 representation at the start? Yeah. Okay, so if you guys are fine with this, then we can move on. So chapter 9, I haven't got any homework. Enrique just sent me one, and I didn't have time to look at it. Let's see how much we can have finished. So you've done this. So let's have a look. So chapter 9 was basically some arithmetics in base number systems, right? And oh, Rika, so you meant this. You meant these ones. So the ones with letters in them. Okay, all right. So let's do a few ones with letters in them. That's only feedback I've got. So this one, right? F. Okay, to do this, does anyone remember what letters represent?
Like 10.
Yeah, exactly, right? So our digits run out. We run out of digits when we get to 9, right? So from 10, we have to use the letters. Okay, we can remember, right? So basically, it's gonna be 0 from 0 to 9, and for 10, it's gonna be A. For 11, it's gonna be B. So A actually means 10, B means 11, C means 12. If it's if the base number if the base system is more than 12, you might have more. Okay, so you're just gonna see them as 10, 11, or whatever. So to do this question, we can do a long addition, right? It's 3, 9A plus 4, 8, 8 in base 12. Okay, so what this means, what base 12 means is that whenever you have a 12, you have to carry over. Okay, Rika, that makes sense? And Aaron, that makes sense, right? Whenever you have a 12, you carry over. So first we do the unit digit, that's A plus 8. A is actually 10, okay? So this is actually 10 plus 8, which is 18. Now, 18 is more than 12, right? So you have to carry over, okay? So if 18 is more than 12, you carry over. So you carry over 112. That means 18 minus 12, you have 6 left. Does that make sense? Okay, I'm gonna write down here, A plus 8 is actually 18, right? So since you need to carry over 12, when you carry over, 12 is gone, right? So you're gonna minus 12, and you have 6. This is very similar to a decimal system where you have to carry over 10, remember? In decimal system, when you carry over 10, you minus 10. See that you have 6 plus 8, that's 14. And out of this 14, 10 is carried over to the next digit, right? So you only have 4 left in that digit. Does that make sense? 认可你明白吗？对吧？是不是跟十是一样？你在十进制里面就是逢十进位嘛，所以呢，你比如说你得到了14，你进10就进位了，剩一个4，对吧？那么在这个12这个 system 里面，是不是逢12进位啊？你算出来这个直线算完了之后，每12进一个位嘛，那剩下的呢？剩下的只能放在这儿，这是6。Okay, ba, everyone? Okay. So here we have a 6 here, and we carry over 1. And again, so does anyone want to do the 10th digit here, the second digit? 9 plus 8 plus 1. How much is that? Anyone?
18.
Yeah,
So
that's
you
18.
carry, so you carry 1 over and it's 6.
Yes. So same stuff, right? You get 18, you carry 1 over, you have 6. And the last digit will be Aaron. What will be the last digit here?
8.
8? Yes. It's 3 plus 4 plus 1. So 8. And it's in base 12. And that's it. So the answer would be A66 in base 12. Okay, Rika, that makes sense? Yeah. Another way to do this is you can always use the digit bundles to represent them. Remember the digit bundles, which means, those times 12 to the power 1 times 12 to the power 2 kind of stuff. Okay, but that's a lot harder. I think this one should be much easier. And this one, using this method shows your understanding of different number bases and and the basic arithmetic of additions and stuff. Okay, so let's do one more example. And this one, let's say anyone other than Aaron, because I think Aaron understands it. So Ryan, I think you're fine with it too, but if you want to do it, you can do. Lily and Rika, anyone want to try this? 1, 2, D, 9, 4.
那 D 不是 A B C， A B A 是11 ，B 是12
A 是11吗？
？A 是10 ，B 是11 ，C 是12 ，D 是13。
对，就依次往下数就行了啊，因为 A 是10啊，10开始就没有一个单个的数字了嘛，所以就要用字母 ，OK？
那我能写出来用10吗？就我写
那你写个10
10
不就变成这样了吗？
1
多一个 digit 看到吧？对不
嗯，
对？你变成10，你要写10的话，是不是多了个 digit？ 你看，本来4位数给你写成5位数，那大小就不一样了，对吧？对吧？因为在这个16这个 number base 里面，你是要到16才进位嘛，所以你必须要给10、11、12、13这些都发明一个符号，对不对？那我们肯定不希望发明一些不认识的符号，我们就用字母来代替而已，明白吧？OK 嘞，瑞卡，那要不你来做一下？
我先想一下。
你先想一下逢16进位啊，Lily 可以吗？Lily，你这道题试一下，那你做，这样跟前面一样 ，OK？Just the same as this. Number base 12. Whenever you reach 12, whenever you have anything more than 12, you carry over, and after carry over, you should subtract 12 from the sum. 怎么样，Lily？ OK 啊，不行的话，能做吗？你要觉得不能做，我就请 Ryan 做，好不好 ？OK， 那 Ryan 你来试一下。但是 Lily、Rika 你们好看清楚怎么做啊 ，All right？
就个位是6。
对，个位是 so unit digit 2 plus 4 is 6, right? Very easy.
Yeah.
And then
这个位应该是4。
yes, very nice. 是4啊。我们来看一下这个 so let's look at the second digit, right? It's B plus 9. So B plus 9, B is actually 11, right? So plus 9, it should be 20. And it's in a base 16 system. So it's more than 16, you have to carry over, Lily. Okay, right? So this is 20, you carry 116 over, you only have 4 left. Okay, you have 20, 16 of the 20 should be carried over to the next digit, right? So you only have 4 left. So you're gonna put a 4 here and then carry 1 over. Okay, that makes sense, Lily? And the next one, Ryan, what about
然
this?
后下一步这个应该是对呀，这个应该是 F。
非常好. Exactly, okay. The next digit is 1 plus D plus 1, right? So 1 plus D plus 1, you can always think D plus 1 is E, and then E plus 1 is F, right? Okay, or you can always go back to this number. 13 plus 2 is 15. What is 15? You go E is 14, right? And F is 15. And it happens to be number base 16, so it's just gonna be F. Yeah, Rika, yeah, that's correct. Very nice. Okay, very good. So what about A plus 2?
C.
C, right? A, B, C. Really, that makes sense? A plus 1 is B, B plus 1 is C, right? So we put a C here, and no carryover, just 1. So the answer should be 1CF 46. 1
So when you said D plus 1 plus 1, why can't it just be 1, 3 carried over? Because D plus 1 plus 1 is 15. 15 minus 12 is 3. So why can't it be 1 carried over and then 3 written on the bottom?
1 carried over and 3 written on the bottom. But why? Sorry, I didn't get it. So D plus 1 plus 1, right? So look at here. So Aaron, D plus 1 is it E? It is, right? And then plus another 1, you get F. And that's it. You cannot carry over because you
Right, can carry over. Yeah,
Yeah.
sorry, I was wondering in base 10.
Oh, okay, yeah. So in base 10, you can carry over and you have a 5 here because you have 15, right? For 15, 10 carried over, you have a 5 left, okay? If it's in base 12, then there will be, 12 of it carried over, there'll be a 3 here. I think you was thinking about thinking in base 12, okay? But this is in base 16, so you have to reach to 16 and then carry over. Okay, that makes sense? Yeah, and also if it is in base 12, you wouldn't even see a D. D is 13, right? So yeah. Okay, Lily, does that make sense to you now? Yeah. Basically, in any number system, when you reach it, you carry over. So if it is more than that, then you just minus 1 that base number from it, and you will know what number is left. It's very much like the decimal system, right? In our ordinary regular decimal system, when you do an addition like this, you're gonna minus 10, remember? So for example, like 48 plus 76, what do? 6 plus 8 is 14. So 8 plus 6 is 14, but this is in base 10, right? So that's why you minus 10, you get a 4. There's a 4 here, you carry over 1. That 1 carried over means a 10, right? It's 14. So that's why the 10 carried over. Because whenever you reach to 10, you have to carry over. That's base number 10. Make sense? Yeah. And then 4 plus 7 plus 1, again, 4 plus 7 plus 1 is 12. It's more than 10, so you carry over. So you get a 2, you carry over, you get another 1 here. Okay, Lily, that makes sense? Everything is not changed. All these numbers just come from your addition. And the reason why we are subtracting 10 is because it's a decimal system. If it is number 16, base number 16, we're minus 16. That's it. If it's base number 12, then we minus 12. Okay, Lily, I think that makes sense to you? Okay, good. Wonderful. And then let's move on. Yeah, then I don't have any other homework from Rika. So then let's maybe do just from every part, every section, we're gonna do a few ones with the letters with them, okay? With the letters, and let's just practice. So let's say we do one here, this easier one, and then we do K. K is like you're gonna subtract 2 numbers. So this one, see if anyone wanna volunteer.
So we can write it vertically first.
Yeah, like a long subtraction, yes. So we write down maybe here. So 3, okay, next page, 3CD77, and then 19E8E. And again, just for your convenience, I'm gonna bring these over here. Okay. Oh, Rick already found the answer. Very nice. So,
Since 7 can subtract E, we can borrow another 16 over, then it's 23 minus 14, then that would be 8.
8.
Oh,
Okay.
no, probably not. Sorry, I did the math too much.
Yeah. E is 14, right? Uh-huh.
9.
Would be 9. Yes. Good. Borrowed one. Okay. So for the borrowing, Lily, does that make sense? Why is it 9? It makes sense? Okay, good. So when you borrow one, notice that you are not in a decimal system. So when you borrow one, it's not just going to be 17. Because when you borrow one, you're borrowing 16. It's a base number 16, right? You only have, so when you carry over, you reach to 16. When you borrow one, you are borrowing 16, not 10, okay? In base number 12, you're borrowing 12. In base number 10, you're borrowing 10. In base number 8, you're borrowing 8. Same as addition, okay? So when you borrow one, it basically becomes 7 plus 16 minus E. And E is actually 14, right? So you can change this to 14, and you will see that it's 2 plus 7, that would be a 9. Okay? Okay, good. Let's do the next. When you borrow one, that becomes 6 minus 8. What do we do?
You borrow again. So
You
D
borrow
will,
again.
does this mean that D will turn to, we borrow 16 over again. So that's 22 minus 8. So that's 14.
Which is?
Oh, 14 is E.
Yes. So we put an E here. Okay, Lily, does that make sense? Here you borrowed one, so it'll be 6 minus 8. 6 minus 8 is not enough. It's -2, right? So you have to borrow another one. So let's mark it. When you borrow another one, you are borrowing 16 again, right? So this is -8. You're borrowing 16. That means you have 14. 14 is Z. So you put an E there. Okay, Lily, that makes sense? Yeah, good. Next. So Erin can continue.
It turns into C. So C minus E, you have to borrow again.
Yeah.
So 16 plus C is 28. 28 minus 14 is 14. So 14 is E again. So we write E again.
Yeah, so we write E again and we borrow one again. Good. And then
this turns into B, and B minus 9 is 2, and B 9.
yes. Very good. Okay, so Rika, the answer sent to me was correct, right? Okay, very good. So I think Rika totally get it. Yeah, and Erin got it. And Lily, any more question about the subtraction? Lily, you're fine? Okay, good. So Lily, I'm gonna make you do one exercise, and I think that'll be okay for everyone. So let's do this. Which is base 11, okay? So base 11, you just need to know A is 10, right? It wouldn't be too hard. Let's write it down. A0, A1, 3087, 2AA7. Okay, so ready? How do we get started? Lily, 来，我们快做完了。 怎么做啊？ So 1 minus 7 minus 7 is not enough, right? You have to do what? 是不是
对
Lily 啊？是不是不够减的时候你要干嘛？
borrow
你要 borrow, exactly, right? So if you borrow 1, is that enough? When you borrow a digit from here, that means how many have you borrowed?
10 more
10? I see.
11
Yeah, 11, right? It's base 11. So remember, when you have 11, you carry over. So when you borrow 1, you're borrowing 11. Make sense? Because 1 0 in 1 0 in base 11 means 11, right?
yes
Yeah. Okay, good. So if you borrow 11, is it enough?
no
No, it's not enough, right? So that means, what do we do?
borrow 2
Yeah, borrow again, right? So you can put another dot here, we can write a 2 here, right? So you borrow another one, so that means, yeah, how many you have here? Do you have here?
like 23 minus 14
Very good, yes. And what is 23 minus 14?
9
9. Very nice. Okay, you've got it. Great. What about here? So this is a minus 8 minus a, and since you borrow 2, you have to minus another 2, right?
Yeah.
So what do you think?
do we also minus like 22
Minus
here?
20.
Or is
Yeah,
it just 2
you just do, yeah, this you just minus 2, right? The top, because you borrowed 2, so you have to minus 2. So just a minus 8 minus a minus 2. If it is not enough, you borrow, right?
so a minus 8 so negative 10
Yeah, very nice, right? So a and a cancel, you're gonna minus 8 and you minus another 2. So that means you're gonna minus 10, right?
yeah
So that's not enough. What do? You borrow, right? So you borrow 1 from here.
that'll be 1
There'll be 1, exactly right. Because yeah, you borrowed 11 minus 10, you have 1 here. Very good. Okay, what about this digit?
negative 1 minus a
So that means how many should we borrow from the next digit? If we borrow 1 number here, does it work? You borrow 1, then you're borrowing 11, right?
yeah
11 minus a, you get
what is a
a is here. A is 10.
oh
A is the
okay.
first letter, right? A is the first letter, so it represents the first number after 9. Because after 9, we don't have any digit, we use letter, right? So remember that A is 10. This is easy to remember, okay?
So 10 minus 10 is 0
0, very good. And lastly, what is the first digit?
so then 4
Very good, yes. So it'll be 10 minus, yeah, so 9 minus 5, so 4. Okay, so in base 11. Does that make sense now, Lily? You borrow it, you borrow 11, not enough, you borrow 2 11s, that kind of stuff, okay? And A is 10, B is 11, C is 12, you just move on. Okay, good, very nice. Multiplication. Let's try again, do some stuff with letters in it. Does anyone want to try and see if you recall how to do multiplications? Okay, let's maybe go over the ways to do multiplications. Okay, there were two ways, remember? One way is to use the digit bundles, but in the last lesson we showed this and it was obviously very difficult, right? Here. So for example, like this 2 4 1 times 3 1. If you just use digit bundles, you have to do distributions all over. That means you have a lot and you have to carry over. So it takes a long time, right? So that means maybe you want to do something else, something like constructing a multiplication table and use that table to complete your multiplication, right? But I also explained that to make a multiplication table isn't easy. It's gonna take a long time, right? So except in situations that you have to do multiple multiplications, you don't really want to make a multiplication table. Because if you make one table for one question, it's gonna take too much time, right? But in this case, you can still so when you're doing multiplications, you need a multiplication table, but for something like 2 times a, in this case, you can always figure it out. You can figure it out yourself. Okay, so let's have a look using this example. In this example, we have 192 times 3AA, and that's in base 11. We can first do it regularly, just like this. Okay, and let's figure out step by step. Okay, figure out the multiplication step by step. So first, we have to do 2 times a, right? What is 2 times a in base 11? How do we think about this? Okay, I'm gonna give you guys an example. It's not hard. You can always convert it back to decimal, okay? So remember that we call that a is 10, right? If a is 10, 2 times 10 is 20. It's 10 plus 10, 20, right? And 20 in base 11, that means you have to put a 1 here. And 1 means 11, right? For the second digit, 1 means 11. So that means you have another 9 in base 11. See if that makes sense. This is literally a plus a in base 11, because it's 2 times a, right? 2 times a means a plus a in base 11. And a plus a, you can do 20, you can just do anything, like previously we've done addition and subtraction, right? So it's going to be 20, and you're going to carry over, so you have 19, 19. Does that make sense? Everyone, okay? So the first multiplication here, 2 times a, we get 19, so we write a 9 here, and we carry over 1, okay? The next stuff we have is 9 times a. 9 times a. You can go back to decimal system again. I believe that would be the easiest. Okay, so 9 times a, that's 90, right? And once you get 90, you have to figure out, for every 11, you're gonna carry over, right? So how many 11s are there in 90?
8.
There were 8, exactly. So if you put an 8 here, that means you already have 88. And for 90, you have a 2 here. So 82 in base 11. Does that make sense to everyone? Right? This gives you 90, but it's in base 11. So you're gonna see how many 11s do you have? You have 8 11s, right? So you put an 8 here, and 8 in the second digit in base 11 means 88, and you plus another 2. So that means this is actually 90 in base 10 in our regular number system, and this is also 90. So they're equal. Okay, so that means you have a 2 here, and you have 8 as a carryover. I hope that makes sense to you guys. Okay, if that makes sense, then we'll move on. Another way to do this, you can also do something like a distribution stuff, right? For example, if we are doing base 10, let's use base 10 as an example, and let's show how to use that in base 11. So in base 10, say that you are doing 8 times 9 in base 10. Other than reciting the multiplication table, we can also do 8 times 10 minus 1, remember? Like from very elementary school. And then this gives us 80 minus 8, so we get 78. Right? So here we can do the same thing for 9 times A if you want. It can be 9 times for A. A is actually 1, 0 minus 1 in base 11, right? This is everything is in base 11. Because A is 10. A plus 1 is 1, 0 in base 11. So we can also do this. And that means 9 times 1, 0. Recall that in any base number system, if you time by 1, 0, you just add a 0 at the end, right? So here is going to be 9, 0 in base 11 and minus 9 in base 11. And since in base 11, when you borrow 1, that's 11. 11 minus 9 is 2, right? And you borrow 1, that's 8, 2, 11. So that could also work, okay? But I think if you just transform everything back into decimal system, that ain't hard, okay? And the last one is 1 times A plus 8. So 1 times A is 10. 10 plus 8 is 18. For 18, you carry 1 over, minus 11, that's 7. Okay, make sense? Okay, if that makes sense, we do this next step. So the next step, 192 times A is the same, right? It's the same as the first row, right? 192 times the first A and then 192 times the second A. So it will give you the same answer. So that means we have 1729 again. Okay, and in the end, we have 192 times the 3. So 2 times 3 is 6. 9 times 3 is 27, right? 27, that's in base 11. So that means you have a 22 carried over, and you have a 5, right? 23 times 9, 27. That's in base 11, right? So you carry over 2, and you have a 5. 27 minus 22, you have a 5, right? And in the end, you have 1 times 3 plus the 2, you have a 5 here. And eventually we do some addition. 9, just drop down. 2 plus 9, that's 11. And you happen to have 11, so you just get a 0. Carry over. Okay, and then what do we have? We have 9, 10, 16. So 16 minus 11, that's 5. Carry over. And then 8, 13, 14. So 14 minus 11, that's a 3. Carry over. And then we have 1 plus 5, 6 plus 1, 7. And there we go. Okay, and again, and also since we observe that here we have 3AA. So since we have a 3AA, you can also do this question by this. 3AA plus 1 is 400 in base 11, right? So you can also do 192 in base 11 times 400 in base 11 and minus 1. You can also do this. And this you can do it very easily with just mental calculation. So because this way you only need to time the 4, right? You only need to time the 4, so that's 0, 0, and then you time the 4 and stuff. Okay. And in the end, you're minus 192. I hope that makes sense to you guys, how to do the multiplication. So let's do another example, and then, okay, maybe we'll take a break, and then we will do another example and do some division, and yeah, that's probably today. Okay, let's take a break. Let's come back maybe 5 minutes, 10, let's say 10 minutes, okay? It's 8:20, come back 30, okay? Okay, I'll just continue. I just found that I made a mistake here, okay, in question E, because you see this 9 times A is A2. So I wrote down the 2, but I forgot there's a carryover, right? It should be 3. Okay, so I was having this weird feeling that this is not correct because if you do a quick calculation here, right? It's 192 times 400, you end with 2 zeros, and when you minus 1 times 192 is 192, right? So 0 minus 92, you should have 0 minus the 2, you borrow 1, that's the 9, that's correct. But if you borrow another 1 minus 9, here should be a 1, right? So that's why I figured I must have made a mistake. So the mistake is here. Okay, I forgot this carryover. So to correct that, we're just gonna change this 2 to 3, right? Let's change this 2 into a 3. I'm gonna wipe it out. And let's do these 2 parts again. So this should be a 3, this should be a 3. So that's why here we should get a 1. Because this 3 plus 9 is 12, right? And then carry over, and that's 17, right? 3, 6, 1, that's 10, plus 7 is 17. 17 minus 1 is 6. Okay, all the other ones are the same. Just a little mistake, and yeah, and this one makes more sense. Again, here, because of here, right? 0, 0 minus 9, 2 should get 1, 9 in base level. Okay. Okay, let's perhaps do one more practice and get someone to do it. Let's see who wanna give it a try. When you do multiplication, you can always convert it back to the decimal system. And whenever you reach to the number base, you carry over, right? Do this kind of stuff. For example, you can always do 3 times 5 is 15. But 15, there were 2 6 in it, right? So you carry over 2, and you have a 3 remaining. That will be 2 3. That's how you do it, okay? You can always use the decimal system. So anyone want to try this? Rika, want to give it a try?
I have a question.
Mm-hmm.
So every time we have a number multiplying by a number in a base other than 10, we just we multiply it first as if it were in a decimal system and then convert.
Yeah. Now that's the easiest way, I believe. Okay. Yeah, because
Okay.
you do 3 times 5, you can convert them back to decimal system, which is still 3 times 5, right? So that will give you 15 in base 10, and you convert that back to base 6, right? To convert it back to base 6, you just 15, there were 2 6 in it, right? So you get 2 and you have a 3 in base 6. Yeah. Okay, I think so. Rika, you just gave me an answer. Let me see. 1 0 0 2. Yeah.
对的
Okay.
吗？
对的. So Rika already provided me with a correct answer. So Ryan, are you good with this? Any question? Okay, Aaron, do you want to try, or do you think it's fine? You can do it as homework. Okay. Then we.
I can try it if you want me to.
Do you feel confident doing it as a homework question?
Yeah, I can do it as homework. Yeah.
Okay, yeah. I mean, if you feel confident, then we're just gonna skip it, okay? If you feel like you need some more practice to understand, then we can do one. But if you feel confident, then we skip this. You can do it as homework, okay? And then we'll see if you got it correctly. So then let's go to division. Yes. For divisions, let's do an easy one first. So in the text, it actually has introduced many ways to do divisions. Okay, so I'm not sure if you guys have read it. Probably not. Okay, see, they have 4 different methods to do it. But there were digit bundles. There were just doing this long division and kind of stuff. Okay, or you can always convert them back to decimal system and to a division. Okay, but I think personally I believe that doing this long division is the easiest. Okay, so let's try this long division. So 1, 3, 4 base 9 divided by 7 base 9. Try an easy one and try some harder ones, and I think that'll be good. Okay. So this, just do it as regularly, but remember you're in base 9. Okay. So what do we do? Anyone? What is the first number we can get up here?
One.
1. Very nice. Yes. So 1 is not enough for the 7. Of course, we do 1, 3, right? 13. And even in base 10, 13 is not enough to get a 2. 2 times 7 is 14, right? And in base 9, it will be even more. For example, 2 times 7, 14 in base 9, because whenever you have 9 carry over, you actually have 1, 5, right? So it's actually 1 more. So we get a 1 here, we put a 7, and we'll do a subtraction. What is 1, 3 minus 7 in base 9?
Like
The 1,
5.
yeah. So the 1 here can be seen as a 9, it's base 9, right? So when you borrow a 9. 9 plus 3 is 12. 12 minus 7 is 5. So this is 5 and a 4. How many 7s are there in 5, 4 in base 9? For this,
Like 7.
7. Yeah, very good. How did you guys figure out the 7? I think the easiest way is to convert this. I don't know. I mean, my way is to convert this back to decimal system. I'm not sure if how you guys figure it out. Okay, if you have any ways to figure it out, you feel good, you can share it with us. Okay. So my way is always to convert this back to decimal. That's 5 times 9, right? 45 plus the 4, 49. So it's actually just 49 divided by 7, that's 7. And that's it. No remainder. So 1, 7 in base 9.
Why do we have to convert, like when we subtract every time, why do we have to convert it to a decimal?
When we subtract, that's okay. We don't have to convert back to decimal. But I meant that when we do a division.
Yeah, like why do we have to convert it to decimal?
Because it's easier. I'm not sure how you figure it out. For me, I feel like I kind of have to convert it back to decimal, because not converting to decimal, then you have to try numbers. And again, if you try 6, if you try 7, if you try 8, then that means you have to do a lot of multiplication here to determine the correct answer, correct number, right? I'm not sure how you did it, but I believe that converting to decimal is the easiest, because converting back to decimal, we can just use multiplication table that we are familiar with, right? Yeah. It's not a necessity. I mean, if you don't convert back to decimal, for me, I think I can only just try numbers. I can try a 6, I can try a 7, I can try an 8, kind of stuff, right? And see if that works. And every time when I try, I have to do a multiplication, right? And to do a multiplication is like doing decimal again. Remember, when we do multiplication, we're actually doing decimal system again, right? 9 times 8 is 90, 90, and you convert back to the 11, base 11. That's 8, 2. Okay. Let's do one more question. Maybe do some harder ones. So maybe do this, and then we can look at the example with the letter on it. So this should be pretty easy because we've got a bunch of 8, 1 here, right? 8, 1, 8, 1, 8, base 11, divided by 8, 1, base 11. Shouldn't be too hard, anyone? You can, I think you can even do it with calculation.
Is it 1010 in base
Yeah.
11?
Exactly, 1 0 0 1 0, right? Because first you put a 1 here, that's 81, and that's gone, right? And then you drop an 8, doesn't work, so another 0, and you drop the 1, and that's just gonna be 1, and that's gonna be 8 1, and that's gone. And you drop the 8, not enough, so 1 0 1 0. Remainder is 8, right? So the answer would be 1 0 1 0 in base 11, and you have a remainder of 8. Okay, make sense? So next we have this thing with a letter. So you could do 9A71B, that's in base 16, divided by 3E9 in base 16. The calculation here could be a lot, okay? We first 3 digits, right? So of course we use the first 3 digits. What is 9A7 divided by 3E9? How many are there?
I have a easier method.
Okay, go ahead.
We can convert every number to decimal and then divide by decimal and then convert back to 16.
Yeah, that okay. Converting back to decimal would always work. Yeah, and especially for difficult numbers like these, yeah, we can always do that. Yeah, but for this number, you see, this number is pretty big. It's 9 times 16 to the power 4, right? So without a calculator, it could be, well, it could be a lot of calculation too. So I think, we can just try to do this directly on this number base and try to be familiar with number base calculations, right? Yeah. The problem with converting back to decimal with this one is that if you don't have a calculator, it's gonna take a long time. This is a big number, okay? So, but just do it directly. It wouldn't be too hard. So 3E9, this is 9A7, right? So we can try what? Do we try 3 or do we try 2?
2.
2, right? Because if we try 3 times E, that's a lot. That has to carry over, right? You wouldn't get a 9. So you can try a 2. Okay, that makes sense? And now this is the time to test your familiarity with multiplication, okay? So if you're familiar with multiplication enough, you can do this like mentally, right? So this is 2 times 9, that's 18. And this is base 16. So for 16 of the 18, you have to carry over. That means you have 2 left, right? That makes sense, guys? So 2 times 9 is 18. 18 minus 16 is 2. So you put a 2 here and you carry 1 over. Okay, and then 2 times E. What is E again? Remember A, B, C, D, E, F? For number base 16, it's A, B, C, D, E, F from A to F. E is 14, right? But again, let's just pull it down for you to consider. Just for convenience, okay? But this you have just, it's not hard. It's kind of remember it, right? A is 10, E is 14, okay? So now E is 14. 2 times 14 is 28, plus the 1 is 29, right? For 29, there ain't 2 16s, there's only 1 16, right? So 29, so maybe I'll write it on the side so that you know what I'm talking about, okay? We are doing 2 times E, okay? So 2 times E. E is 14, that's 28. Plus the 1, here's 1 carryover. So that's 29. and it's more than 16, so we minus 16, we get 13, and 13 is actually D, okay? So you put a D here, and you carry over. And eventually 2 times 3 is 6, 6 plus 1 is 7. So just put 7 here, and do a subtraction. Okay, so 7 minus 2 is 5, A minus D, that's not enough, that's 10 minus 13, that's negative 3, right? So you have to borrow 1. And when, after you borrow 1, that's negative 3 plus the 16, that should be 13. And 13 is D. That makes sense? Okay, and then since you borrowed 1, that's 9, borrowed 1, that's 8. 8 minus 7 is just gonna be 1. Okay, and then you drop 1, drop the next digit 1 down here. It's 1D51. It seems like we can put a 3 here, right? This time. If you put a 3, 3 times 3 is 9, and some carry over, it should be good enough, yeah? So we put a 3 here. No, what I'm talking about. Okay, wait. Not a 3. 3 is probably 1. This is 5. A minus D is D, yeah, and borrow 1D, yeah, 1D. So let's think. 1D is a D. D is really big, right? So if you put 3 there, okay, maybe we can see this as a 400, right? Try to pretend it to be 4, and then look at this 1D. 1D is actually 1 and 13. So it's sort of like 23 in decimal, right? So actually we should put a 7 there. Yeah. Okay. So you know, to test out the next number, maybe convert to decimal again. This 1D is actually 13, right? So if we go back to decimal, this becomes like 23, right? Because D is 13. 23 divided by this 3, you should put a 7, right? So we should put a 7 here. But let's give it a try. You know, you have to try, right? So let's try 7. 7 times 9, that's 63. So maybe I write down here. 7 times 9 is 63. And you want to see how many 16s are there in 63, right? We know 4 times 16 is 64. So we can only do 3, right? So 7 times 6 is 63. That's basically 64 minus 1. And 64 in base 16, that's 40. That's 40. And in base 16 minus 1, so you get 3F, right? So you put an F here, and you carry over 3, and you do 7 times E, that kind of stuff, okay? Yeah, I think the calculation is more than is a lot. Okay, so I'm just gonna skip this for now. You can do this homework, you know, as homework, and try to do this. And if you feel like there's too much calculation, you can actually skip it. It's fine, okay? Because usually you wouldn't be solving this kind of division in exam or anywhere. Okay, I'm just gonna skip it for now, and then let's look at review problems. So Reika, you said you did review and challenge. Did you encounter any hard problems that you want to talk about?
就是 because like I 我之前没有很熟练的用那个 A 嘛 ，A something
所以只是字母你不会是吧？
对。
那你到了 challenge 这边都做出来了，没有什么问题吗？
challenge 只做了前5道，后面没有继续做。
前5道都会是吧？
Yeah.
Okay.
Just like the last few ones.
Okay, let's just do maybe this here we have an AMC question. Let's do this. Okay, so this is for everyone. Let's try to do this, and then yeah, we'll have a look. So we have a product 12 times 15 times 16, each factor written in base B. And this equals to 3146 in base B. And S is 12 plus 15 plus 16, each term expressed in base B. Find the value of S in base B. So if you want to find the value of S in base B, you have to know what B is. Does that make sense, right? Because you actually know what S is in decimal system, just add them up, right? But what if this value expressed in base B, then you have to know what B is. Different B's gives you different representations. Yeah?
So we already know that 12 times 15 times 16 is 3146. Because it says
12,
equal.
yes. Yeah.
Yeah, so we can find.
These three factors are in base B too, okay? Because
Okay.
he said, yeah, each factor.
Okay.
Like this. Yeah. So 12, 15, 16 are not in base 10. They're not decimal numbers. Each okay. But how do we convert this to an algebraic equation?
So written in base B would be 1 times B plus 2 times 1 times B plus 5. Yeah.
And 16 will be B plus 6, right?
Yeah.
6. Yeah. And then equals to 3
times B to the power of 3.
Yeah. So 3B cubed plus B plus 4B plus 6. 6 can be a very similar this, to this. 6. 44 very good. Yeah, Rika 已经找到44了，非常好啊。Rika 怎么做的呀？你是这么做的吗？
差不多。
Okay, good. Yeah. So going by this, we can find out what B is. Okay. Let's expand it. So here we have B cubed. And for B squared, I'm gonna give you guys a trick. Okay. I'm not sure how you guys open up the brackets here. So maybe I presume you open up the first bracket, right, like this, and then you write on the product and you open up the second. If you do this, then I'm gonna teach you a trick here, okay? Give you a trick here. Very easy, very fast. So okay, and also, Lydia, I think you probably are you are not aware of this way to open up brackets. So have a look. So notice that we have B plus a number times B plus number times B plus number. So that means in our result, we must have a B cubed. We must have a term with B squared. We must have a term with B, and we must have a term with just numbers, right? Constant numbers. Make sense? So we just need to determine the coefficients of each term. How do we do that? To figure out the coefficient of B cubed, that's very easy here. You're just gonna do B times B times B, right? And none of them have any coefficient other than 1, so that's just a 1 here. That's very easy. But what about B squared? So think about how do you even generate a B squared from 3 brackets? That means you have to do B squared, you have to do B times B. And the next bracket, you have to choose a number, right? So it has to be B times 6. This way gives you 6B squared. But other than this, you can also do B times 5 times B. That will give you 5 squared, right? And in the end, you can also do 2 times B times B. what I'm saying here is that in order to get a term b squared, you have to get two b's in two brackets. Okay, so Rika, I know, yeah, we'll finish at 6. So you have to get two b's in two brackets. Does that make sense? OK， 这个有没有想明白 Rika？OK 吧？要拿到一个 b square 这个 term， 是不是要在两个括号里面找到 b， 剩下的一个括号就得选一个数字啊 ？Right? So to generate a b squared, we choose two b's from two brackets, and the last bracket you have to choose the number. So that means you do b times b times 6, you get 6b squared, and then there's a 5 here, right? So 5 times b, that's 5b squared. And also, if you get a 2 as a number, that means you have 2 times b, that's 2b squared. See? So this way you can mentally calculate that basically for b squared, that's just 2 plus 5 plus 6. And that will be 13. Does that make sense? Okay, good. And then what about the term with only b? So if you want a term with only b, that means say that the first bracket, if you use the b, then the second bracket and the third bracket, you can only choose the numbers. For example, here, b times 5 times 6, it gives you 30b, right? And also if you choose b from the second bracket, there'll be 2 times b times 6. If you choose b from the third bracket, that's 2 times 5 times b. So in other words, the coefficient of b here is actually just the product of 5 and 6 plus the product of 2 and 5 plus the product of 2 and 6. So basically, the product of any possible pair of numbers. 没问题吧？就是这个，如果你要出现一个 b 的话，维卡是不是你就需要你选一个 b， 剩下两个括号都要选两个数字啊？所以如果你的 b 出在第一个括号里，那剩下两个括号只能出数字，就是给到你30b， 对吧？你的 b 如果出在第二个括号里，那剩下两个括号里只有2跟6，就给到你12b。如果你的 b 出在第三个括号里，那就是2跟5，就是10b。其实说白了就是3个数字两两相乘相加，没问题吧 ？OK， so this gives you 30 plus 12 plus 10. That's 40 plus 12, so 52. Okay. And then for the numbers, I believe you guys know, for the numbers, just do number times number times number, right? So 2 times 5 times 6, that's 6, that would be 60. Okay, so this method works for any sort of opening up brackets. No matter how many brackets you have, you can always use this kind of thinking, okay? But maybe later on, we will see this trick, okay? Let's see this method in other questions. But anyway, here we just get an algebraic equation like this. And if we simplify, I'm just quickly go over this. If you simplify, you get this. Okay, this is a cubic equation. We haven't learned, or we won't be learning. We won't even learn how to solve this kind of equation, right? But in math 12, in like regular school math, or in AMC 12, we will be learning a special way called rational root theorem to test out a root. But for here, you will see that since we have 3, 1, 4, 6 in base b, so b has to be greater than or less than or greater than or equal to 7, right? You have a 6 here, so b is greater than or equal to 7, and b is also an integer, so you can try. You can try 7, doesn't work, try 9, try 8, doesn't work, and if you try 9, you will see it works. Okay, so for here, you don't actually need any advanced, algebra knowledge to solve for it. You just need to know that b is greater than or equal to 7. So you try 7, you try 8, you try 9, and that works. Then you can know what b is 9. And after you know b is 9, then that's it, right? So s is 12 plus 15 plus 16. That's going to be 12. Again, 12, 15, 16. They're also in base b. So 12 plus 15 plus 16, all in base 9, and this should give you 44. 4 in base 9. Okay, you can choose. Okay, yeah, so that will be all.